So let's see what is MAC flooding. Content addressable memory CAM table is limited in size. The CAM table is flooded with more MAC addresses than it can hold. The switch enters into fail open mode and will turn into hub. Attacker exploits this vulnerability in the CAM table to sniff network data. After the switch turns into hub, attacker then changes her machine's NIC to promiscuous mode to enable the machine to accept all the traffic entering it. MAC flooding switches with MACoff. MACoff is a Unix Linux tool that is part of the dsniff collection. It floods the local network with random MAC and IP addresses. The command is MACoff minus MACoff minus I. I is for interface. In the example, the interface is ETH0. So MACoff minus I, ETH0 minus N. N is for number of packets to be sent. In our example, it is 10. So MACoff minus I, ETH0 minus N, 10. Important note, MACoff sends the packet with random MAC and IP addresses to all active machines in the local network. So after MAC flooding, we'll see switch port stealing. Okay, in this, the attacker floods the switch with ARP packet with source MAC address set to target's MAC address and destination MAC address set to its own MAC address. Remember, actually the source is the attacker himself, but actually he's setting his MAC address as a destination. So when he does this, a race condition of the attacker's flood packets and target host packets will occur. I will try to explain the race condition here. When an attacker sets his MAC address as a destination, the switch updates its ARP cache table, as initially this MAC ID belongs to another IP and port. So there will be two rows with the same MAC ID. Both the rows will contain attacker's MAC ID now. The victim's MAC ID will be replaced by the attacker MAC ID. That is, this row will contain victim's IP and attacker's MAC. So if the victim sends a ARP packet with its correct MAC ID, then the switch will again update the ARP cache and the row corresponding to victim will contain the correct MAC. This way, the switch has to keep updating its table frequently. This is the race condition that the Aspen book is talking about. So when this is happening, when the switch keeps updating its table frequently, if the attacker can slow down the victim, then the attacker's MAC ID will be present for more time in the ARP cache table, and the packets intended to the victim can be received by the attacker. So, I mean, the attacker, what he does is he will launch a denial of service attack on the target machine, on the victim's machine, so that it will be slow and the attacker can respond fast. So this way, he can start sniffing the victim's messages. This is switch port stealing. So